Hello guys, welcome back to Games Academy. In today's video, we're going to dive into procedural generation. Specifically, I'll show you how to generate dynamic platforms using Perlin noise in Unity. Whether you're working on a 2D or 3D game, procedural generation can help create unique, infinite levels that keep the gameplay exciting. Let's jump right in. What is procedural generation? It's a method of creating content algorithmically rather than manually. This means instead of designing every individual platform or piece of content in your game, procedural generation allows you to generate them based on a set of rules or mathematical functions. This can be used to create landscapes, levels, or even storylines, and it's especially useful for generating large, dynamic worlds with minimal manual input. It helps save development time while giving your game infinite possibilities. There are several types of procedural generation, including random generation, the most basic form of procedural generation, where elements like platform positions or obstacles are placed randomly within a defined space. It's fast, but can feel repetitive without additional logic. Noise-based generation, this type uses mathematical noise functions like Perlin noise to create more organic, smooth variations in content, such as terrain or platform heights. This is perfect for creating levels that feel more natural and less predictable. Rule-based generation. Predefined rules dictate how content is generated. For example, you might specify that a platform must always be above a certain height or be connected to other platforms. This type gives you more control over the structure of the generated content. L systems used for generating plants or branching structures. L systems use a set of rewriting rules to simulate natural growth. This is popular in procedural plant generation. Dungeon generation. This type focuses on creating labyrinths or dungeons, often using algorithms like cellular automata, random walk, or binary space partitioning (BSP) to generate interconnected rooms, corridors, and obstacles. This is popular in roguelike games where the player's environment constantly changes. Biome-based generation. This method generates different environments like forests, deserts, oceans, and mountains. It relies on noise functions and predefined rules to generate areas with specific characteristics based on their coordinates or terrain type. Let's talk about how we'll use Perlin noise to generate our platforms. Perlin noise is a smooth, continuous function that's perfect for creating natural-looking terrain. Unlike random noise, which can create sharp, jarring transitions, Perlin noise ensures that our platforms have smooth transitions and feel more organic. It's ideal for terrain generation, as it mimics natural patterns like mountains, valleys, and oceans. In this tutorial, we're going to use it to vary the height of our platforms as we move across the level. This makes each platform feel like part of a seamless world rather than a disconnected series of jumps. Why we use procedural generation. Procedural generation is a powerful technique in game development that allows for the creation of vast, dynamic worlds with minimal manual effort. It generates endless content, ensuring players always encounter new and exciting experiences. By automating content creation, it saves time and resources, enabling developers to focus on core gameplay. Procedural generation increases replayability by offering unique content with every playthrough, and it creates organic, natural-looking environments. Additionally, it reduces memory and storage requirements, scales well for large worlds, and provides unpredictability, which keeps gameplay fresh and engaging. This makes it an invaluable tool for developers creating expansive, ever-changing game worlds. Let's break down how to create a 2D platform using Perlin noise. First, we need to create the dirt prefab. Right-click in the hierarchy, click 2D object, then sprite, and choose square. Rename the created sprite to dirt. We can change the color of the sprite to brown to look like ground. Next, we need to create the grass. Duplicate the dirt object, rename it, and change the color to green. Now, drag and drop both objects into the asset folder to make them into prefabs. Next, we'll create a script for the platform generation. Create an empty game object, rename it Platform Generator, and create a new script called Platform Generator. Open it in Visual Studio. This script generates dynamic platforms in Unity using Perlin noise for procedural generation. The script starts with serialized fields that allow you to adjust various parameters like the width and height of the platforms, the minimum and maximum height for the terrain, the number of repetitions for the terrain, and references to the prefab objects, dirt and grass, used to build the platforms. There's also a button object, generate button, which triggers the regeneration of the level. And the start method sets up an event listener for the generate button so that when clicked, it calls the generate new level method to regenerate the platforms. The generate method handles the overall platform generation, iterating over the width of the level. For each X coordinate, it checks whether to apply Perlin noise to determine the platform's height. Then it generates the platform by calling the generate platform method. The getHeightFromNoise method calculates the height for each platform using Perlin noise. The X coordinate is used to generate a smooth noise value, which is then scaled to the desired height range from min height to max height and randomized with some variation. This creates organic, natural-looking variations in the platform heights. The generate platform method loops through the height of the platform, instantiating dirt objects at each Y coordinate. Once the platform body is created, it spawns a grass object at the top to complete the appearance of the platform. The spawn object method is responsible for instantiating the platform objects at specific coordinates and parent them to the platform generator for better scene organization. Finally, the generate new level method clears any existing platform pieces before regenerating the level, ensuring a fresh layout each time the button is pressed. This process allows for dynamic platform generation that changes every time, creating a varied gameplay environment. Great, save the code and head back to Unity to see how platform generation works. Now, we need to assign the values in the script through the inspector. Set the width to 100, the minimum height to 20, the maximum height to 5, and the repeat number to 3. Next, drag and drop the dirt and grass prefabs, and also drag and drop the button. That's it, guys. Now hit play. When we run the game, the script will use Perlin noise to calculate the height of each platform at a given position. The height is determined based on the X0, with the Y position controlled by the Perlin noise value, creating smooth elevation changes across the platforms. To ensure variety and make each platform feel unique, we add a random factor to the height calculation. This introduces small fluctuations in height, so no two platforms are exactly the same. This randomness is subtle enough to keep the level looking natural, but adds just enough variation to make the gameplay interesting. If we click the Generate button, new levels will be generated. And that's how we create dynamic platforms using Perlin noise. Procedural generation not only helps create variety in your game levels, but it also gives you the ability to generate endless unique content. Whether you're making a platformer, an open world game, or even a roguelike, procedural generation can add a lot of depth and replayability. By using Perlin noise, we ensure that our generated platforms feel smooth and organic rather than random and disconnected. Additionally, procedural generation opens the door to other exciting uses, like generating complex dungeons or biome-based worlds. Thanks for watching. If you found this tutorial helpful, don't forget to hit the like button and subscribe for more game development content. If you have any questions or suggestions, drop them in the comments below. I'd love to hear from you. And as always, happy game developing, and I'll see you in the next video. Happy game developing, guys.